and I. Those are our initial guide columns. Initial guide columns. So in this procedure, which is way different from the short method, you need to complete the columns under every symbol in the first premise before you move on to the second premise. And then complete columns under every remaining symbol in it before you move on to however many premises there are, and finally the conclusion. We only have one remaining symbol in each case. They're all horseshoes. So you're using the truth values of their antecedent and consequent, and according to the definition of a horseshoe. You all know when it's false, right? There's only one case in which it can be false. Every other case it's true. Right? So you have to know those definitions of your symbols. That horseshoe is the first premise. That horseshoe is the second premise. Did I ever mention the shortcut to reading this? Okay, then I'll mention it. What are we looking for? This is an analog to your Venn diagram. So you diagram the premises and you read the diagram for validity. Well, we're not diagramming premises, we're showing all possible truth-value combinations of them, given all possible truth-value combinations of their simple statements. But we're still looking for this sort of the same thing. What are we looking for? What? What we're looking for is something that's either here or not. I mean,
Aren't we looking for two true premises with a false conclusion?
Well, there could be 1,000 premises, all true premises and a false conclusion. That's what we're looking for, right? Since that's not possible in a valid argument form, if it's possible here, then this argument form is invalid. What's your proof of validity in the long truth table?
Two true premises.
No.
If there is no mistakes, if two true premises and a false conclusion do not exist, then it's valid.
The absence of any invalidating row. You guys remember this, right? It's the presence of at least one row on which all premises are true and the conclusion false that proves invalidity. It's the absence of any such row that proves validity. So a row on which everything is true means absolutely nothing. A row on which everything is false means absolutely nothing. So here's our shortcut. Since we're looking for at least one row on which all premises are true and the conclusion false, it follows that we only have to check those rows on which the conclusion is false, right? And that would be, looks like 2 and 6. So see what the premises are in 2 and 6. Are any of them invalidating rows? Somebody says row 6. Let's see. True, true, false. That's a proof of invalidity. Questions? It's a very simple procedure. Absolutely no reason to get any part of this wrong in the test. The translation might be the most difficult thing. Now, just as on the first test, I asked you I made some true-false statements about your diagram to make sure you're doing the diagram right. You know, sections 2 and 3 are crosshatched. You remember that, right? Something like that? Well, I want to make sure you're doing this procedure right, not just guessing about validity. So I'm going to ask you what some rows or columns look like. I'm going to give a series of T's and F's on the test and say this is what the column under the first premise looks like. So this is the first premise column right here. If you have the T's and F's that are on the test, then that would be a true answer. If you did it right. Right? Let's do the short truth table proof of this argument. This argument forms for this procedure, we want to set it up vertically. Somebody make me happy and tell me how we start this procedure.
We make the conclusion false.
Oh, there's a little bit more to it than that.
The what? I mean the horseshoe, sorry.
We assume the argument form is invalid. That means that it's possible for the premises to be true and the conclusion false. That's an assumption. Right? What we're looking for here, in this case, we're looking for row 6. Or in any case, we're looking for an invalidating row, which would exist on the long truth table, or at least one of them. Yeah. So we want to proceed by supplying, if possible, and it almost always is, only truth values of which are certain. Did you remember any of this? We're not certain of these truth values because a horseshoe could be true in 3 cases. Same here. There's only one case in which a horseshoe is false. So the conclusion is the place to start. Not because it's the conclusion, it's because they're the only symbols whose truth values we're certain of. And what does H and I have to be?
True, false.
Get in the habit of circling an assumption that you justify. You know what I mean by that? I know how that horseshoe could be false if H is true and I is false. There, I justified it. Anybody remember what we want to do next in this case? Transfer the truth values to any occurrences of H or I. Do not forget to do that. What can you tell me about G in the first premise, its truth value? Anything?
It has to be. In the second one.
No, you can tell us something about G in the first premise.
Well, it works with both.
It doesn't matter what G is in the first premise. So we have the convention of using that slash. Do you all understand why it doesn't matter? Because when you look at your truth table definition of a horseshoe, you guys have to be familiar with these things. Where the consequent is true, that horseshoe is true. It doesn't matter what. See if that's. We have a row on the definition of a horseshoe that says false, true, true. We have one that says true, true, true. It doesn't matter what G is up there. So you have to be confident about your definitions in order to use the slash. If you're not confident, you're going to be reluctant or not know that you can use it. Ladies and gentlemen, don't ever transfer a slash. Like to the other G here? No. This means it doesn't matter what its truth value is in this premise. It sure does matter here. or it could in some other case. Never transfer a slash. Okay, what can you tell me about G in the second premise? It has to be false. Anybody not understand why? You get a test next week. Anybody not understand why? If you don't like that slash being there, you can now say, okay, well, make it false. I don't mind the slash there. That's a true horseshoe. Okay, I think if you'll check row 6 of our long truth table, this is it. See, we just found it. Next. Looks like we have only 3 simple statements. Japan does something. Notice how this disjunction, the left-hand disjunct, is not explicitly stated. Perfectly fine in English. It's a very economical language. This disjunction is either Korea will suffer economic decline or Laos will suffer economic decline. Bless you. But of course, that would be listed in the key. See this right here? Bless you. This says Korea will suffer. This says Korea will not suffer. So this requires a curl. Okay, the rest of it's pretty straightforward. Go ahead and give us a translation. Bless you. We'll do a long truth table proof, and we'll do a short truth table. What kind of punctuation you give us on that first premise? If we put that punctuation around J horseshoe K, then our statement would become a disjunction. And the first English word should be either. In fact, the first 2 should be either if. I don't think they are. I think the first one is if, isn't it? Did I forget a curl? Oh, curl goes there. Yeah, so it goes around the disjunction. Okay, make your initial guide columns. They're the same as in the last argument, the initial value column. So you should have that, or maybe straighter. Is that all on there? Yeah, is that one? Okay, complete the columns under each symbol in the first premise. Now you have to find the next most complex symbol. Or another way of putting that is a symbol whose truth value is a function of truth values already present. So which one is that? The horseshoe or the wedge? Horseshoe. It's the wedge, because the truth value of the wedge is a function of the disjuncts K and L, and those truth values are present. The truth value of the horseshoe is a function of antecedent J, and consequent wedge. The wedge has not been determined, so we can't determine the truth value of our horseshoes. Do you understand what I'm saying? It's crucial. Okay, wedge first, then you're using J and the wedge to determine the horseshoe's truth value. When's the only time the wedge is false?
This one circle.
When's the only time a horseshoe is false?
When it's antecedent true, consequent false.
That should be the columns under your first premise. Boom, right there. Unless I made a mistake. Good. Second premise, only one column to complete, the curl. Done. Yes, did I make a mistake? What?
I think number 8, in row 8, the horseshoe should be true.
Nice. Thank you. And then the horseshoe in the conclusion. I didn't do it right. My initial guide columns in the conclusion were bad. Sorry. Let that be a lesson to you online students when you're watching these videos. Sometimes I make mistakes and no one ever catches it. It's the way it goes. And now we have to read our truth table. What are we looking? We now are concerned about no other columns than the one under the horseshoe, the curl, and the horseshoe. Right? Forget about it. What are we looking for? Let's take our shortcut. Looks like 2 and 4 are the only rows we have to check, if you ask me. What do you think? So, do we have any invalidating rows? No. Nope. Let's knock out the short method. We'll take a break. We begin with an initial assumption of invalidity. So I assume when our compound statements get complex, that is, they get long, have punctuation, you could at least identify the defining symbol, the main connective or the operator curl. Those are the symbols that our T's and F have to go under. All right, there are 2 places to begin here. Find a symbol or more whose truth value you're certain of. K. Now what? What? Search for some symbols whose truth value you are certain of. J and L in the conclusion. What must they be in order for that horseshoe to be false? Now what?
Transfer to the top.
Transfer.
Now what can you tell me about that width?
It needs to be true for the
Well-
horseshoe to be true, and it can't be true, so.
What is it?
False.
So let's make a point here that you must remember. There's a lot of things you have to remember about this procedure. But when you complete truth values under every symbol in an entire premise, or it could be the conclusion, and especially when that has been done by your transferring truth values, and this has in part, we transferred K and L up there, I think, if I remember correctly, right? You can't think that everything's all right. It might be all right, but you have to stop and make sure all those truth values do justify the initial assumption. Or some other assumption that was made elsewhere. But they don't. Because a true antecedent and a false consequent, they make a false horseshoe, not a true horseshoe. So you may have done this up to the point where we just did and not pause to make sure that all those truth values are good. They're not good. But this argument form is, isn't it? Yeah, that means it's valid, right? Because the failure is not because we're not good enough at this, it's because it can't be done. Why can't it be done? There's no invalidating row on the long truth table. See? And we just did the long truth table. There weren't any. Right? Break time.